Good afternoon. We are going to do notes for 7.6. Title is Proportional Lengths. All right, so Roman numeral 1, we're going to start with the triangle proportionality theorem. This says if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. All right, we're going to prove this as well as practice doing a proof that uses some of our new reasons. So given triangle RST, RST is the big one. PQ is parallel to RS. So that's if a line is parallel to one side. So those two lines are parallel. So of course in the given section, it would be PQ parallel to RS. We want to prove that RP over PT, so we want to prove that RP over PT is equal to QS over ST, that it divides the sides into proportional pieces. All right, let's do this. So PQ parallel to RS, that's a given. So the first one says angle 1 congruent to angle 2. Let's mark that. So angle 1 congruent to angle 2, and angle 3 congruent to angle 4. So we have two parallel lines cut by a transversal. 1 and 2 are both in the upper right. 3 and 4 are in the upper left. Excuse me. So if two parallel lines are cut by a transversal, then, and when they're in the same position, they're called corresponding angles. They are congruent. So I now have a little triangle, big triangle RST, and the little triangle PQT as similar to each other, and that would be our angle-angle similarity postulate, because they have two pairs of congruent angles. Okay, now that we've got that, and there is a bit of a typo here. Instead of RP, that needs to be RT. So RT, which is the left of the big one, over PT, which is the left of the little one, equals ST, which is the right of the big one, over QT, which is the right of the little one. And that's basically true. The ratios are true because we just proved the triangles similar. So this reason would be the definition of similar triangles. Once you get the similar triangles, you get the third angle being congruent and the sides proportional. Okay, so R to T is equal to RP plus PT. That's what this says right here. ST, the big one, is equal to SQ plus QT. We're going to take these and substitute them into this ratio. So what allows us to do that? Well, part plus part equals whole. That is segment addition postulate. It says part plus part equals whole. Substituting those into the ratio, that is substitution property. Again, these are old properties. And then to go from here to here, you can look up the property, but we want to see if it's possible to go from there to there. So let's do that down here before we do our final answer. So RP plus PT over PT equals SQ plus QT over QT. And we want this to look like this. So first thing we need to do is get rid of the PT on the left and the QT on the right. We're going to do that by splitting RP over PT plus PT over PT. I'm just splitting that fraction up. Same thing over here. SQ over QT plus QT over QT. Of course, anything over itself is 1. So I have RP over PT plus 1 equals SQ over QT plus 1. And then I can subtract over to the left, and I'm left with RP over PT equals SQ over QT, which is what we have right there. If you do a bunch of algebra, and you go from this step to this step by doing basic algebra moves, your reason is always algebraic properties of equality, which basically means we did a bunch of algebra and got from there to there, which is really nice. It's a lot briefer than having to label every one of these steps. Okay, flip the page. Okay, so remember that a corollary means it's so closely related it didn't have to be proved separately. So this is the corollary to the triangle proportionality theorem that says if three parallel lines, so the triangle proportionality theorem is if there was one line parallel to another line that was in a triangle. This one's related because there are three parallel lines that intersect two transversals. So I have Q as a transversal, and I have P as a transversal. Then they divide the transversals proportionally. So how does this work? Well, Q is the transversal. It means that the ratio between RS and ST is going to be the same as the pieces created by the other transversal, which is XY and YZ. So for transversal Q, big piece over small piece, big piece is RS over small piece, which is ST, is equal to, for transversal P, also big piece over small piece, XY over YZ. And we have something we can solve then. Big over small equals big over small. It's a pretty cool theorem, really. All right, theorem 7-4, triangle angle bisector theorem. This one's kind of wild, but it is a lot of fun. So it says, if a ray, and in this drawing, DG is the ray, so ray DG bisects angle FDE, so there's FDE, which is an angle of triangle DEF. So if the ray bisects the angle of a triangle, then ray DG divides the opposite side. So DG divides the opposite side, which is FE. So let me mark this as bisecting because ray DG has to bisect that angle. So if it bisects that angle, then it divides the opposite side, FE, into segments that are proportional to DF and DE. So DF is this one, and DE is that one, which are the other two sides of the triangle. So what do we mean by divide proportionally? Okay, so for the FE, we have a small piece, we'll call that single P, and a large piece, double P. The other two triangles can be divided into small side P and double side PP. So for the red line, for FE, we're going to go small piece over big piece. So the small piece is FG over the big piece, which is GE. That's going to be equal to small side over big side of the triangle. Small side of the triangle is FD, big side of the triangle is DE. So small over big equals small side over big side. And that gives us something that we can use to solve. All right, Let's do an example. Ray BX bisects ABC, and that's already marked, and divides the opposite side of the triangle into CX, which equals 3, and XA, which equals 2. If C to B is 27, find the length of AB, which is X. Okay, so using this theorem, we're going to go small over big equals small over big. So starting with the opposite side, small over big is 2 over 3. And now the sides of the triangle, small over big, is X over 27. Now what you're going to notice is the small piece here is always next to the small piece there. Big piece here is next to the big piece there. So they're pretty easy to spot. That is our equation. So we're going to solve this equation. Start by getting rid of the 27. Multiply by the reciprocal, 27 over 1. That gives you X on the right equals 27 times 2 over 3. So 27 is 9 times 3 times a 2 over 3. Notice I'm not bothering to multiply out 27 times 2. Without a calculator, it's just easier to factor the 27 and factor the 2. And then after things cancel, you have a lot smaller numbers. 9 times 2 is 18. So the length of AB equals 18. Pretty nifty theorem. Okay, flip the page. We're going to practice the corollary. All right, true or false? So, basically, when it comes to either 3 parallel lines or 2 parallel lines, the pieces have to match up. Now, in the case of this drawing, the pieces of AF have to match up with the pieces of FB. Now, we already know by the theorem that the triangles are similar. So any parts of the triangles are going to be proportional, and that was because of angle similarity postulate. So we know they're similar. We just have to match it up right. Okay, so I'm going to use different colors here to try to help it out. FA over HA. So FA over HA equals, now on the right, FB over TB. See how those are actually the same pieces and parts left and right? So that one is true. Let's go on to the next one. FH over AB. So FH is here over AB, which is here, is equal to AH, which is here, over FT, which is here. So I got 2 pieces of the small one and the bottom and the left of the big one. None of that matches up. That's definitely false. Okay, FA over FH. So FA over FH is equal to FT over TB, part and part. So top and whole equals part and part. No, that's false. And the last one, let's see, I'm out of colors. I'll do pink. FA, so the entire left, over FB, just the entire right, is equal to AH, which is the left piece, over TB, which is the right piece. So whole left, whole right, over part of left, part of right, that is actually true. So between the transversals, the same things need to line up. Okay, we're going to do the same thing here, except we have 3 lines that cut 2 transversals into proportional pieces. So here we go. A over B equals C over D. Top, bottom, that is true. Let's do it again. A over C equals C over D. So top piece, this does not match up at all. False. All right, A over D equals C over B. So A over D is top of the left transversal, bottom of the right transversal. That's not proportional. The pieces A to B and C to D are proportional, but you can't take a top left of one, the bottom right of the other. So that one is actually false. And then the last one, B to C, bottom left, top right, equals A to D, top left, bottom right. Again, we're picking pieces apart that aren't going together. B over C, A over D. It wouldn't work like that. It would have to be B over D, A over C. But you can't go crosswise like that. So false. All right, find the value of x. Okay, so we have B to D, and B is the angle that's being bisected. And across from it, we have a side that's being split into two pieces. The left piece is 10. The right piece is going to be the whole thing, x minus 10. Okay? So obviously 10 is smaller than x minus 10. If you weren't sure though, you can tell because the small side of the triangle is next to the small piece. The big side of the triangle is next to the big piece. So we're going to do big over little for both of these. So for the piece, this piece, AC, the big one is x minus 10 over the little piece here, which is 10, equals, now we're going to do triangle sides, big over little, 24 is big, over 12, which is little. That is your equation. And of course, dot, 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 you'd solve, and you would get x equals 30 when you finish solving. All right, number 4, find the value of x. Okay, so our theorem says if you have a line parallel to a side of a triangle, that it breaks the other two sides into proportional pieces. So we have a small piece and a large piece, a small piece and a large piece. Okay, so let's go, since this is x, big over small. So big piece x over small piece 1 equals, now the other one, big piece 8 over small piece 2. That is your equation. And 8 divided by 2 is 4. So x equals 4. Now there is a second way to do this one, and that would be using the fact that you have similar triangles. If you did it that way, you'd have to go left of the little triangle, left of the right. So this side of the big triangle would be x plus 1. This side of the big triangle would be 8 plus 2, which is 10. This would also work. You could go left of the little triangle over left of the big triangle, x plus 1 equal to the right of the little triangle, which is 8, over the right of the big triangle, which is 10. So that's another way you could do this, is by using similar triangles or using the theorem. And the theorem, remember, has an actual name. It is triangle proportionality theorem. Triangle, we're going to write that down. Proportionality theorem. That's what lets us set it up like that. Whereas this one is similar triangles. All right, that is the last of the notes. Have a terrific afternoon.